Right, this is 6.4, adding and subtracting rational expressions. So for the starter, just make sure that you're finding a common denominator when you're adding them together. So for example, 3 over 7 plus 2 over 3, you have to find that common denominator. So 3 can't go into 7, 7 can't go into 3, so you would multiply each of those by each other. So for the first one, you would multiply by 3 over 3, and the second one, 7 over 7. So 3 times 3, you get 9 over 21, plus 2 times 7, which is 14, over 21. So now you have that common denominator, so now you can add the tops. So 9 plus 14, you're going to get 23 over 21. Can't simplify, so then you would be done. So you would do that for 2 and 3, and then 4, they have a common denominator, so you can subtract. So 4 minus 3 is 1, so you have 1/5. So try 2 and 3, and then submit those on Canvas. And then for our notes, our essential question is, how can you determine the domain of the sum or difference of two rational expressions? Well, the domain is the restricted values, or what x cannot equal for your equation. For rationals, it's what's in the bottom. So we're going to be matching equations with their domains. So for example, let's do A, and then I'll have you do some on your own. So 1 over x minus 1 plus 3 over x minus 1. So they have that common denominator. So remember from last time's assignment, we did excluded values. So remember, we would have x minus 1 cannot equal 0. We would add 1, where x cannot equal 1. So with rationals, when you have your excluded values, it can be all real numbers except your excluded value. So we're looking for our domain that says all real numbers except 1. And that would be C. All right, the next one, we have x minus 1 and x. So we know that x minus 1 is x cannot equal 1 because we just did it above. And then x, remember when it's an x by itself, it's just 0. So you'll have x cannot equal 0. So now we're looking for all real numbers except 1 and 0. So we look, A, B, and D don't work. So we'll scroll down. So we're looking for 0 and 1. And we find F is our only option. All right, so go ahead and pause and work on A through H and match those up to the big A through H and find all your excluded values. For little e, instead of a divide, it's supposed to be a subtract. So fix that on your notes. So cross out the divide sign and replace it with a subtract sign. And then when it's out of order, make sure you write it as x plus 2 in order so that it's in that same factor format. Okay, so for C, when you have the bottom here, remember last time when we went over, if it's a 2 minus x or a number minus an x, you switch it out by taking out the negative. So then it would make it x minus 2. So then they match. So then your exclusion would just be x cannot equal 2, which is G. And then D is letter B. E is A, F is H, G is E, and H is D. All right, so for our core concepts, adding and subtracting, if it has that common denominator, then your C cannot be 0. So that just means your denominator cannot be equal to 0, and you'll have an exclusion there for the domain. So the denominators have to be the same in order to add the tops or subtract the tops together, or the numerator. All right, adding and subtracting with unlike denominators. So remember, you have to multiply by something in order for it to be the same. So since A over C is missing D, you times it by D over D. B over D is missing C's, so you'd multiply it by C over C. So then you have AD plus BC over CD. And you would do the same for subtraction. All right, so we're going to find the sum. So we want to get the common denominator. So what I like to do is I like to write out, so lowest common denominator, I write out all my terms. So I have a 9x squared, and then I have a 3x squared plus 3x. So if we factor out a 3x from each of these, then you're left with x plus 1. So now we can see we can multiply 3 by 3 to get 9. So we have 9. And then x times x makes x squared. And then the 9x squared is missing the x plus 1. So that would be your lowest common denominator. So I'm going to change this over. So now we have to multiply this by x plus 1, and what you do to the top you have to do to the bottom, and then this one by 3x because we want to make it a 9x squared. So you'll have 7 times x plus 1 over 9x squared times x plus 1 plus 3x squared over 3x x plus 1, or 9x squared. Oh, I keep forgetting that. Okay. So now the denominators are the same, so we can add the tops. First, you might want to distribute your 7 though, so it'd be 7x plus 7. So you'll have 3x squared plus 7x plus 7 all over 9x squared times x plus 1. And then you could try and factor the bottom, or the top, sorry. So you have 3x squared, 7. So you have 21, and you want to add or subtract to equal 7. So you have 1 and 21, and 3 and 7. So none of those will add or subtract to ever equal 7. So it's not factorable on the top. So that would be your answer. And then our restrictions are what our lowest common denominator would equal. So you have 9x squared cannot equal 0. And then x plus 1 cannot equal 0. So we divide by 9. Square root. So you just get x equals 0. And then subtract 1. So you have x cannot equal 0 and 1. So your domain would be all real numbers except 0 and -1. On your assignment, if you don't simplify anything, then it's just going to have you write your answer. It's not going to ask for the domain. So when you're writing your answers, The only time it will have you do the exclusions is if you simplify something out. So kind of like our last assignment where we only included the values that we canceled out. So since we didn't cancel out anything, we just leave that as our answer and you would be done. All right, finding the difference. So we want to factor this. So we're going to divide out a 2 from each. So you'll have x plus 2 over 2 times x minus 1 minus negative 2x minus 1 over x squared minus 4x plus 3. Now you can distribute your negative at the beginning or at the end. It doesn't matter. So if we do that, we have x plus 2 over 2 plus, so negative times a negative makes a 2x, and then negative times a negative 1 is going to be plus 1. So then we have x squared minus 4x plus 3. And then we need to factor that bottom. So we have x squared, x, and 3. So we want factors of 3 that add or subtract to equal negative 4. So we only have 2 choices, 1 and 3. And then it's a negative positive, so that means both of them are negative. So it'll be negative 1 and negative 3. Then we choose our common terms. So x squared and negative 3x have an x in common. Negative 1x and 3 have just a negative 1 in common. And remember, you match the sign. X squared and minus 1x, negative 3x and 3 just have that negative 3 in common. So then I'm going to rewrite this as x minus 1, x minus 3. So remember, you need your lowest common denominator. So we have 2 times x minus 1, and then we have x minus 1 and x minus 3. So notice that they have x minus 1 and x minus 1 already in common. So that means we only need to multiply by an x minus 3 and by a 2. So it'd be 2 x minus 1, x minus 3. So this one is missing the x minus 3, and then this one is missing the 2. So to write that, so you'll have x plus 2 times x minus 3 over 2 x minus 1, x minus 3. You don't want to simplify yet, so you just leave it. And then 2 times 2x is 4x. 1 times 2 is 2. And then we're going to write it as 2 x minus 1, x minus 3. All right, you will have to multiply out the x plus 2 and x plus 2x minus 3. So you have x plus 2. So remember, it's just the reverse of factoring. So x times x is x squared. X times 2, 2x. Negative 3 times x is negative 3x. Negative 3 times 2 is negative 6. Then remember, we add our like terms together. So we're going to have x squared minus x minus 6 plus our 4x plus 2 all over 2 times x minus 1, x minus 3. All right, then I'm going to bring it up here, and I'm going to add like terms together. So we have x squared plus 3x, and then negative 6 and 2 makes a negative 4, all over our 2x minus 1, x minus 3. And now we want to factor that top to see if we can get factors that will cancel in the bottom. So you have x squared, x, negative 4. So factors of negative 4 that add or subtract to equal 3. So you have 1 and 4, 2 and 2. It's a positive negative, so little numbers are negative. So it'll be that negative 1, positive 4. So x minus 1, x plus 4. So now it's x minus 1, x plus 4 over our 2x minus 1, x minus 3. So now we have stuff we can cancel. So we have an x minus 1 on top, x minus 1 on the bottom. So we cancel those out. And then remember, those get in our excluded values. So x minus 1 cannot equal 0. So we add 1. So x cannot equal 1. So we have x plus 4 over 2 times x minus 3. And then we include that restriction because it only wants the ones that we cancel out when you write your answer. So this is how those will look if you stumble upon one that has an exclusion on your assignment. It's because it canceled something out. So always be sure to look for those. Otherwise, you just write your answer. All right, these next ones I'm going to have you do on your own. So go ahead and pause and then try each of these and then come back and check your answers. All right, for your answers, so you get 21 minus 4x over 28x for A. For B, you get x to the third plus 3x squared minus 4. So that doesn't factor nicely, and we didn't learn kind of how to factor those x to the thirds when they weren't perfect cubes, like the sum of cubes, difference of cubes. So we're just going to leave it like that. And then the bottom is 3x squared times 3x squared minus 4. So none of these we didn't simplify, so we won't have any excluded values for our answers. And then C, you have 17x plus 15 over 12x minus 4x plus 3. So always when you're looking at your common denominator, you always look and see what they have in common. So for example, B had a 3 in common, C had an x minus 4, so you don't have to re-multiply that to the ones that already have that there. So just something to look out for. And then if they don't have anything in common like A, you would just multiply those together. So that's how we got that 28x, because you do 4x times 7, which gives you that 28x. All right, this is an honors only topic. So if you are not in honors, so 6th and 8th period, for my classes, you will not be doing this section. So you are good to go work on your assignment, and don't forget to do your exit ticket. So simplifying complex fractions, so it kind of works in a similar way to what we've been doing already. So method 1 is you simplify the numerator and denominator by writing each as a single fraction. Then divide by multiplying the numerator by the reciprocal of the denominator. Method 2, you multiply the numerator and the denominator by the lowest common denominator of every fraction in the numerator and denominator, then simplify. So I'll show you both ways. All right, method 1, it wants you to first combine your fractions. So we would need to combine the bottom. So our lowest common denominator of the bottom is x times x plus 4, because they don't have anything in common. So you just multiply those together. So we're missing an x here, and then x plus 4 on this one. So I'm just going to leave 5 over x plus 4 over, and then we have x times x plus 4 plus 2 times x plus 4 over x plus 4. So then you can add, so we'll still leave this here. So then you'd have a 2x plus 8. So x plus 2x is going to be 3x, and then plus 8 over x times x plus 4. I'm not going to distribute that because it will cancel when we do the multiply by the reciprocal. So now, since there are single fractions on top and bottom, so you have 5 over x plus 4 times x plus 4 over 3x plus 8. So now the x plus 4's cancel, and you're left with 5x on top and 3x plus 8 on the bottom. And then remember, if we cancel something out, it says, okay, so the x cannot equal -4 because that's our x plus 4 cannot equal 0. And then remember at the beginning of 6.3, if we include that in a denominator anywhere in our fractions, we have to include it in our restrictions. So it will also be x cannot equal 0. Even though it ended back up on the top, when we flipped it for the reciprocal, you still include that for your exclusions. So on these ones on your assignment, when you're doing them, you will have your exclusion. So if you simplify something out, or if it's that one that is that denominator number that gets flipped, always include that in your restrictions. So always check for that. All right, the second method is where you multiply everything by the lowest common denominator. So 5 over x plus 4 over 1 plus 4 plus 2 over x. So we're going to multiply the top by x times x plus 4, and then the bottoms by that x times x plus 4. So on the top, the x plus 4's simplify. And then on the bottom, you have 1x, and then the x's simplify. Then you have 2x plus 8, which then becomes 5x over 3x plus 8. And then since we crossed out the x's and the x plus 4's, you'll have your restriction of -4 and 0. So that's how you do it the second way. So whichever way you like to do that for your complex fractions, go for it. Whichever one makes the most sense and is the easiest for you to understand, I would choose that method. All right, and that is it. And then you'll do your exit tickets. So make sure, because we didn't do a common denominator, so let's do one of those really fast. So let's go back up to our common denominator ones, because somehow they got skipped. All right. So a common denominator, let's do a couple examples. So 8 over 12x minus 5 over 12x. So when they're the same, you don't have to multiply by anything. So then it would just be 8 minus 5 over 12x, which is 3 over 12x. And then you see if you can simplify. So 3 over 12 becomes 1 over 4, and then the x still stays in the bottom. All right. Let's do another one. So we have 2x squared plus 2. 2x squared over x squared plus 1 plus 2 over x squared plus 1. So the common denominators are the same. So you have 2x squared plus 2 over x squared plus 1. Then we can factor out a 2. So you'd have x squared plus 1 over x squared plus 1. And those cancel. So you have 2. But remember, we include our restrictions. So we subtract 1. So you have x squared equals negative 1. So remember when this happens, so it makes an I. So you'll have an imaginary restriction. So we don't include that in our restrictions if it's an imaginary number. So the answer would just be 2. All right, and that's what it looks like when you have a common denominator. So you should be able to do those ones that are the common denominators. You just see if there's anything that can simplify, just like we've been doing with the ones that don't have a common denominator. And then remember, as always, you can ask me questions and you can work on your assignment.